Hi, I'm Jason with MathTutorDVD.com, and today in this lesson we're going to cover the topic of finding the common denominator between two or more fractions. And it's just a very important topic that you'll be using pretty much from here on out. No matter what math class you're in, you're always going to be dealing with fractions. And so at some point you're always going to be dealing with finding the common denominator. So in this section, that's all we're going to focus on, is we're going to take two fractions, maybe sometimes even three fractions, and we're going to practice finding the common denominator and transforming that fraction, one or both of those fractions, into a form where both of them have the same bottom number. That's finding the common denominator. Now, the reason you do that is because in a few minutes, when we get over into the next section and the one after that, when we begin to add and subtract fractions, I'll give you a little preview here. When you add or subtract fractions, the denominator of those two fractions must be the same. In other words, you must have a common denominator, which just means the bottom number has to be the same in those fractions before you even can add them or subtract them. So it's kind of like a first step you have to get and you have to master before you can ever pretend to add fractions to get the right answer. So rather than combine this skill along with the adding fractions, I split it up. So in this section we're going to practice finding the common denominator, and in the next section, when we get over to addition, subtraction of fractions, we'll use this skill in order to be able to do that. So the first thing I want to do in this section is just remind you, what do I mean when I say find a common denominator? All I'm really saying is that let's take a fraction that we understand, that we're really familiar with. Let's think about pizzas again. What if we have 1/2 of a pizza? We've talked about this a lot. What does that fraction mean? It means if I take a pizza, which is right here in front of us, and I divide it into two pieces. That's what the bottom number means. So I'm going to cut it only into two pieces. But I don't have both pieces. I only have the top piece. So that means I have half of a pizza. And that's exactly what you would think about when you open a box and say, hey, give me half a pizza. That's what you would do. You would cut it in half. You'd take half the thing. But if I also looked at you and I said, hey, give me 5/10 of a pizza. Most people would be a little bit confused. Why would he want 5/10 of a pizza? What does that mean? But you would do it the same way. You would take the box, right? And you would probably cut it in half, right? And then you would cut it again in half. And then you would cut it again in half. And about this point, you would count, how many pieces do I have? 1, 2, 3, 4, 5, 6. Well, I'm going to cut it in half again. It's going to give me 8 pieces. That's 7, 8. And I'm going to cut it in half again, 9, 10. So these pieces are not equal because I'm not a great artist. But if you had a pizza slicer and you measured it out, if I cut it into 10 equal pieces, there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I only have 5 of them. So I would take this piece. It's 1, 2, 3, 4, 5. So these 5 pieces over here, I would actually take away. Now again, you got to pretend that these pieces are equal because I'm doing things freehand here, but in a fraction it's important that all the pieces that you divide up are exactly equal. But you can see in this case that neither person is the winner as far as who has more pizza, because both of these people have exactly the same amount of pizza. This guy has this much pizza altogether, and this guy has this much pizza altogether. Both of them represent half of a pizza. It's just that this fraction looks a little bit different, but it's not a better fraction or a worse fraction. It is just a different way of writing exactly the same amount of pizza. So the way that we can go back and forth between these two fractions here is basically, in other words, what I'm trying to say is these two fractions are exactly equivalent to one another. They represent exactly the same amount of pizza. And so if I gave you the fraction 5/10, and I said, hey, how would we simplify that? Then you would go off and divide it by 5 and divide it by 5. Or I could say, well, how would I take 1/2? And, what if I wanted to make the denominator 10 to match the denominator of the other fraction? Well, you can multiply or divide a fraction by any number you want as long as you do it to the top and to the bottom. So if I multiply this by 5 in the bottom and by 5 in the top, then I have not changed this fraction because I'm doing the same thing to the top that I'm also doing to the bottom. So I'm multiplying it by something, but I'm doing it to the top and to the bottom. So 1 times 5 is 5. 2 times 5 is 10. So I'm proving to you, based on this little idea that you can multiply the top and the bottom of a fraction by anything you want, to show you that 1/2 is actually equal to 5/10, which is what we've shown here. So if I wanted to change this denominator of 1/2 to 10, I can do it by just multiplying it by something to make it equal 10. I just have to do it to the top. And that's really the secret in all of fractions. We already know we can simplify fractions by dividing the top and the bottom by any number we want. Well, you can change a fraction by multiplying the top and the bottom by anything you want. It's fine. So that's what we're going to do in this section. And this is just one example to show you. But what if, let's don't draw any more pizzas. Let's just say, what if I have the fraction 1/3 and 1/9? These are two different fractions, and I want to basically find the common denominator, transform one or both of these fractions into being the same thing. Well, right away I look at 3 and I look at 9 and I say, well, 3 times 3 is 9, so what if I just work with this fraction? What if I take 1/3 and what if I multiply it, multiply the bottom by 3 and the top by 3? Because 3 times 3 is going to give me 9, 1 times 3 is going to give me 3. So this fraction, 3/9, is now in a form that can be directly sort of compared with the other fractions. So this fraction, 1/3, we've transformed it into 3/9. So these two fractions, if I wanted to write it out, the two fractions that we now have are 3/9, 1/9. And we've sort of transformed the original two fractions. Of course, we didn't have to do anything to the 1/9. We left him alone. But we played around with this fraction and made him into 3/9. And now these two fractions are exactly representing the same amount of stuff as these original two fractions. It's just that now the denominator is the same. And so we're not going to get into this in this section, but that's going to let you add those or subtract those. Later on you could do that. You couldn't do that until you found the common denominator. We'll get into addition and subtraction in a minute. But right now we're just focusing on the skill to simplify those fractions. What if you had 1/4 and 1/8? 1/4 and 1/8. So you look at it and you say, well, which fraction can I play around with to multiply by something to give me the other guy? Well, I know that I can multiply 4 times 2, so I'm going to put 1/4 here. And if I multiply the bottom by 2 and the top times 2, then on the bottom I'm going to have 8. 4 times 2 is 8. 1 times 2 is 2. So this fraction, this 2/8 fraction, it's exactly the same amount of pizza, so to speak, as the 1/4 of the pizza. It represents the same thing. So if I were going to rewrite these fractions in terms of a common denominator, it will be 2/8, 1/8. So again, I didn't have to mess with the second fraction in this case. I left it alone, but I changed the first one. These two fractions are the same two, basically the same two fractions, that represent the same exact stuff as the original two that we had. What about 2/3 and 1/12? How can I do that? Actually, let me write it like this, 1/12. I'll write it below. Okay, so I want to find a common denominator between these two fractions. Well, I know right away that I can take 3 and multiply by 4 to give me 12. So I can say 3, this is 2/3, right? And I can multiply by 4 on the top and the bottom, and that's going to give me on the bottom 3 times 4 is 12. 2 times 4 is 8. So this fraction 8/12 is exactly the same as the fraction 2/3. So the two fractions I started with were 8/12 and 1/12. So these two fractions are just sort of like, I didn't really have to mess with 1/12. I left him alone, but this guy we changed around into this fraction. It represents exactly the same amount of stuff. But in this case, both denominators are the same, and that's going to let me add them or subtract them later on. So you have complete freedom. I can multiply anything I want to a fraction as long as I do it to the top and the bottom, because in that way, if I do it that way, if I multiply by the top and the bottom, then I've continued to keep the seesaw, so to speak, balanced. You can think of every fraction as a seesaw. Everything's balanced. If I multiply something by the top, I've got to do something and multiply the bottom by the same number in order to keep the seesaw balanced. Then I've done the same thing to both sides, so to speak, to both parts. All right, what if I have 3/4 and 5/8? 3/4 and 5/8. Now here, we get into something a little bit more interesting, because we've got 3/4 here and 5/8 here. Now, which of these fractions? Sometimes you have to do things to both fractions, but in this case, I notice I have a 4. So that's going to let me do things rapidly, because I can take this and I can say, we take 3/4 and let me multiply that by 2 on the top and the bottom. Because 4 times 2 is 8, I'm trying to transform that denominator. 2 times 3 is 6, eighths on the bottom. So this is the fraction. I don't really have to mess with this fraction at all, so I'm just going to keep it as 5/8. Now these two fractions have a common denominator. They represent the same amount of stuff. Okay, now what if I have, this one is the one I was looking for, 2/5 and 3/4. Now we start to get into a little bit of a different class of problem. Because if you notice in all the problems before, it was easy to basically find the answer because I could take 4 multiplied by 2 to give me 8. Up here I could take 3 multiplied by 4 to give me 12. Basically in all the other examples I only had to play around with one of the two fractions to get what I was trying to get, the common denominator. But in this case I can't really do that because I can't take 5 and multiply by anything I want to give me 4. It's not possible. I can't take 4 multiplied by whatever I want to give me 5. It's really not possible. But let me show you this. If I take, let me go ahead and play with this fraction. I'm not going to try to explain it in words. I'm just going to show you. What if I take 2/5? What if I just decide to multiply this fraction by 4, top and bottom? And then at the same time with the other fraction, what if I take this fraction, 3/4, and multiply him by 5 on the top and the bottom? Now look at what I would get if I did that. 5 times 4 is 20. 4 times 5 is 20. So this top fraction would be 2 times 4 is 8. 5 times 4 is 20. Bottom fraction, 3 times 5 is 15. 4 times 5 is 20. These two fractions represent exactly the same amount of stuff, just like before. The only difference is, so now we have a common denominator of 20. So these fractions could be added, subtracted, or whatever I wanted to do later down the road when we get there. The only real difference between this problem and the other one is that I had to do something to both fractions. And most of the time you probably will have to do something to both fractions unless it works out really easy where you can just see that you won't have to do that. We've done problems like that before. But most of the time what you're going to end up doing is trying to find, but what we're really doing here is finding the least common multiple between 5 and 4. And so we covered least common multiple earlier in the course, but basically all it boils down to is you're looking at 5 and 4 and you're writing the multiples and then you're finding the least common multiple. But when you're working with fractions, it becomes cumbersome to list them all out and do all of this stuff. You're going to get comfortable with basically finding this common denominator without having to list the least common multiple all the time. In this case, there's no number other, let me say it a different way. The number 20 is the smallest number possible that 5 and 4 can both divide into. If you think about that for a second, you'll agree with that. If you pick, 18, or if you pick 16, let's say, 4 can go into 16, but 5 can't go into 16. What if you pick 12? Well, 4 can go into 12, but 5 can't go into 12. Well, what if you pick, 17? Well, neither one of these numbers go into 17. What if you pick 10? Well, 5 can go into 10, but 4 can't go into 10 evenly. So the smallest number is 20. 5 can go into 20, 4 can go into 20. And so a lot of times you're going to end up doing that. And so we had to mess with both fractions in this case. You're going to get the hang of it, especially with the fact that we're going to do so many problems here. It's not going to be a big deal. What if you had 3/8 and 5/16? Now this is a problem going back to what we did a minute ago where we do not have to mess with both of these because we see that 8 is here and 16 is here. So if I take this fraction and rewrite it as 3/8 and multiply the top by 2 and the bottom by 2, then what I would have is 8 times 2 is 16, 3 times 2 is 6, so I have 6/16. This fraction, if I just leave it as 5/16, now I have a nice common denominator. So in that case, I did not have to mess around with both of them. What if I have 2/9 and 3/18? 2/9 and 3/18. So I look at that and I say, well, I have 18 and I have 9, so all I really have to play around with 2/9 and multiply. What if I multiply the top by 2 and the bottom by 2? Then 2 times 2 is 4, 9 times 2 is 18. This guy I don't have to mess with, 3/18. So these two fractions now have a common denominator and they represent exactly the same amount of stuff. It's the same pair of fractions, it's just this one looks a little bit different than this one. So 4/8 and 3/18. But let's go back and do something a little bit more complicated like we were doing a minute ago. What about 5/6 and 4/7? So again, looking at those two denominators, 6 and 7, there's not really a great number that I can pick that's going to just let me mess with one of these fractions. I can't take 6 and multiply it by whatever I want to get 7, and I can't take 7 and multiply by whatever I want to get 6. So I'm really going to need to play with both of these fractions. The only thing I can really think of is to take 5/6, and if I'm, just follow me here, if I multiply this by 7, and if I multiply, let me make 4/7 here, if I multiply, whoops, this needs to be a 7. And if I multiply this by 6, then what am I going to get? 5 times 7 is 35. 6 times 7 is 42. 4 times 6 is 24. 7 times 6 down here is 42. So notice these two fractions, 35 40-seconds, 24 40-seconds. So if I look at these two fractions here, these two fractions they look crazy, but they're exactly equivalent to these fractions that I have here as far as representing the same amount of pizza. All right, but in this case I had to work with both of them. Now you might have noticed that in both of these cases, all I did was I took this denominator and multiplied by 7, which is this one, and I took this denominator and multiplied by 6, which is this one. So you try to do your best to find the least common multiple between the two numbers, which is what we're doing here. But 42 is actually the smallest number that 6 can divide into and that 7 can divide into. And if you can't find anything smaller, then you'll always be able to find the common denominator by just multiplying the two denominators that you have, which is exactly what we did before. I just didn't really point it out to you. Here we took 5 and multiplied by 4, and here we took 4 and multiplied by 5. So you'll always be able to find a common denominator by taking the two denominators that you have and multiplying them together and making that your common denominator. But in some cases, you'll be able to find a denominator that's less than that, the least common multiple that's even less than that. So if you get stuck, if you can't find a common denominator, you'll always be able to find one by multiplying these two guys together, just like we did here. And we'll do a couple of examples showing that a little bit more in a minute. What if we had -2/7 and 5/14? I just wanted to do this problem to point out that it makes absolutely no difference if one of these fractions or both of them are negative. It has nothing to do with anything. In this case, we see 7 and 14, so I can take -2/7 and I can multiply it by 2 on the top and the bottom, and that's going to give me, negative sign stays out front, 2 times 2 is 4, 7 times 2, 14. This guy can stay the same, 5/14. And those pair of fractions, the 4/14 is the same as this, the 5/14 stays the same. That is a pair of fractions that you could add, subtract, whatever, and I only had to mess around with one of them because the denominators were basically just easy denominators to work with. But here's an example of another one that's good. Let's say I had 7/12 and 7/18. This is a great problem because I'm going to be forced to think of a nice common denominator between the two. What you need to do is say, well, can I take 12 and multiply it by something to give me 18? Not really, can't do that. Can I take 18, multiply it by something to give me 12? Can't really do that. So I need to really think about this for a second. I can't really work with just one of them. I'm going to have to work with both. What you need to do is basically try to find the smallest number that you think that each of these denominators are going to be able to divide into. Another way of saying it, find the smallest number that I can multiply by something by each of these denominators to give me that number. And so the only thing that's really going to work in this case, the smallest number that's going to work in this case is 36, because if I take 7/12, this fraction that I'm dealing with here, what if I multiply this by 3? And what if I take this one and write it as 7/18, and what if I multiply 18 times 2? That may not be something that you see right away, but if you think about it, it's true. 12 times 3 is 36 on the bottom. 18 times 2 is also 36. So I have a common denominator. 7 times 3 is 21. 7 times 2 is 14. So these two fractions, 21 and 36, are exactly The same, 2136 is the same as this guy, 1436 is the same as this guy. Notice they both have a common denominator, so I'll be able to add them or whatever I want to later, but I had to play around with both of them in this case. What if I have 4/15 and 13 twentieths? So 4/15 and 13 twentieths. It's another great example because I cannot take 15 and multiply it by something to give me 20. I can't take 20 and multiply it by something just to give me 15, so I'm going to have to work with both of them. But if I take 4/15, right, what can I multiply by? What is the least common number that I can focus on? Well, you could play around and just kind of go number by number, but just with experience you'll get it. The number 60 is something that will work because if I take, for instance, 13 over 20, if I multiply it by 3, then I'll get 60 in the denominator. And if I multiply this number by 4, 15 times 4 is also 60. So it works out nice because this guy, 15 times 4 is 60, 4 times 4 is 16. This guy, 20 times 3 is 60, 13 times 3 is 39. So what I'm going to have is 16 over 60 and 39 over 60, and they both have the same common denominator. So it boils down to you getting practice with looking at two numbers and figuring out what their least common multiple is. And it's not a skill that just comes overnight, but if you work enough fraction problems, you're going to get good at it. You're kind of increasing the numbers in your head, and you're looking and you're saying, well, what can I divide? What number can I pick that I can basically divide each of these into? Another way of saying it is, what number can I pick such that I can multiply this denominator by something and get that number, and also take this denominator and multiply by something else and get that number. Now up until this point we've taken two fractions, looked at their denominators, and tried to find a number that we can basically use as a guide to transform one or both of those fractions into an equivalent fraction that has the same denominators. And we've always been focused on two fractions, but I want to make sure that you're clear that it doesn't matter how many fractions you're dealing with. You could have 25 fractions sitting in front of you. You can try to find a common denominator between all of them, and it's going to be exactly the same process. So in this case, we're going to do that. What if we have the fraction 1/2 and another fraction that's 1/3 and a third fraction that is 1/4? So here we have three fractions, and I would like to find a common denominator between them. Why? Well, maybe I want to add them together. Maybe I have, half of a loaf of bread plus a third of a loaf of bread plus a fourth of a loaf of bread. Now I'd like to add them together, but I can't do that. I'm giving you a little preview because these denominators are not the same, but we can do that. We can play around with that and figure that out. What you need to do is figure out what is the smallest number that I can use as a guide to target for my new denominator. And so it only comes with practice, really. But I can look at these numbers and figure out that the number 12 is going to work great because I can multiply 2 times something to give me 12. I can multiply 3 times something to give me 12. And I can multiply 4 times something to give 12. If I picked a different denominator, like 8, let's say, yeah, I can take 2 and multiply it by something to give me 8. I can take 4 and multiply by something to give me 8, but I can't do that with 3. I can't multiply by something to give me 8. So let's target 12. And like I say, it just comes with practice. So I'm going to write these fractions over again. Give me a little space. Now, 4, I'm going to multiply by 3 to give me 12. 3, I'm going to multiply by 4 to give me 12. 12, whoops, this isn't 12, it's 2. 2 times 6, I'm going to target to give me 12. And so what I'm going to have, on the top, 1 times 6 is 6, 2 times 6 is 12. 1 times 4 is 4, 3 times 4 is 12. 1 times 3 is 3, and 4 times 3 is 12. So look, that wasn't that hard. It's 6 twelfths, 4 twelfths, and 3 twelfths. And we can add those together, and I'll show you how to do that in the next section. But suffice to say for now, that's basically what you need to do. So doing it with 3 fractions is really no harder. It's just that instead of looking at 2 denominators, trying to figure out what number will be a good one to pick, you have to look at 3 of them. And then you need to manipulate maybe even all 3 of the fractions to get what you're trying to do. All right. Now, I've been talking a lot about using the idea of common denominator to beat your fractions into shape, so to speak, so that you can add them or subtract them. And that's certainly the most important reason why you even care about doing this stuff. But it's also important because sometimes when you have 2 fractions in front of you, if you're not really good at fractions, especially in the beginning, it's really difficult to look at two totally different fractions and understand which one is greater and which one is less, as far as which one's representing more stuff than the other one. And so if you are having a hard time looking at two fractions and realizing which one's larger, which one's smaller, then the easiest way to figure that out is to put them in terms of a common denominator. And then it'll be just like reading it off the page. You won't have to do any work at all. You'll just have to read the